In this video, we're going to be doing some trigonometric substitution. So in the example we have here, we're going to be using the substitution that x equals 2 times the tangent of theta, with theta being between 0 and pi over 2, meaning it's in the first quadrant, to write the square root of 4 plus x squared as a trigonometric function of theta. So what we're going to begin by doing is writing our problem. So the square root of 4 plus x squared. Now we know what x equals because we were told that x equals 2 times the tangent of theta. So we're going to plug that in. So we're going to have the square root of 4 plus 2 times the tangent of theta squared. There we go. Then we're going to go ahead and we're going to distribute that square. So we're going to have 4 plus 4 times tangent squared of theta. So notice that we have a term here and we have a term here. We want to know, what do they both have in common? Well, they both have a 4 in common. So what we're going to do is we're going to factor out the 4, and that's going to give us 1 plus the tangent squared of theta. And looking at this, we know 1 plus tangent squared of theta looks kind of familiar. In fact, if we use the Pythagorean identity, then we know that that's going to equal the secant squared of theta. So what we have here is the square root of 4 times the secant squared of theta. And from here we can separate this out. Let's move this up a little bit. As the square root of 4 times the square root of the secant squared of theta. And we know that the square root of 4 is 2, and the square root of the secant squared is going to be the secant of theta. And that is our solution. So we've used substitution with x equaling 2 times the tangent of theta, where theta is between 0 and pi over 2, to write the square root of 4 plus x squared as a trigonometric function of theta.